Hello, welcome back. Today is a classic restoration case of a Nokia 7610. The phone is covered in a thick layer of mud, caked solid. I use this thin metal tool to pry into the seam, to separate the back cover frame. The frame pops off, exposing the rubber keypad and screen buried in dirt. Using a specialized electric screwdriver with a Torx T6-bit to remove the securing screws. The dried mud flies off with every spin of the high-speed bit. Taking out all the screws one by one, using pointed tweezers to pry the plastic frame protecting the screen. The clay is stuck tight, so a bit of careful leverage is needed. Continuing to slide the tweezers in to peel off the rubber gasket, the screen cushion. The purpose of this gasket is to resist shock and dust, but obviously, the phone has been soaked in mud for too long. The surface of the main PCB is exposed, covered in dirt, along with all surface-mounted components. Sliding the tweezers underneath and slowly prying the main board out of the bottom plastic casing. Separating the screen support frame assembly. The old plastic clips are quite brittle, so prying must be firm but gentle. Lifting the LCD panel off the metal reflector underneath. Picking out the speaker membrane, the microscopic earpiece hidden in the corner of the plastic housing. Now it's time to peel off the physical keypad. The metal domes that create the electrical signal are almost completely disabled by the corrosive layer of mud that seeped in and disconnected the FPC connector to completely detach the screen from the motherboard. Using tweezers inserted into the edges to pry off the white metal shields. For electromagnetic interference, EME, they act as a protective shield for the processor against interference, and this very layer of mud, prying off the shield protecting the RF transceiver IC assembly, and removing the camera module, 1 megapixel. Next, lifting the small metal shield, the final one protecting the radio chip off the mainboard. Prying the plastic frame, then using tweezers to pull out the charging pin assembly, the signature copper-plated circular pins of Nokia. The internal copper contacts have been severely corroded by rust, turned black, pushing the vibration motor out. This eccentric metal weight is the component that creates mechanical vibration for the phone, picking up the power button on the top of the phone. The tweezers must be slid in carefully to avoid cutting the microcircuit. Removing the loudspeaker module using a magnet, and removing the plastic speaker gasket. Picking up the battery contact pins, and the small rubber cushion details, finally taking them out of the phone casing. Detailed teardown of the components. All parts are laid out flat. Everything is completely covered in dirt. Placing the plastic frames and metal shields into the cleaning solution tray, using a brush to vigorously scrub the stubborn mud, and cleaning the inside of the plastic frame, the nooks and crannies with stubborn clay. Moving on to scrub the front cover. The liquid quickly turns a murky color, cleaning the EME metal shields and frames. The brush reaches into every small groove. Most importantly, the motherboard. Brushing over the IX and surface-mounted capacitors. Cleaning the conductive pad, the keypad and the tiny plastic protective covers. Polishing the copper charging contact pins. The action must be decisive. Moving to the deep cleaning step with soapy water to remove the layer of grime. Scrubbing away the stains on the PCB, the screw frames, and the display glass. Continuing to scrub each microscopic component in the soapy foam to wash away the grease. Rinsing all components in a final tray of clean water to completely remove the chemical foam. Starting the drying process. Using a lint-free specialized tissue to dry the motherboard. Drying the back cover over the camera, the rubber cushion frame and surrounding plastic parts. Absorbing the stagnant water droplets on the metal shields, the motherboard, and the display screen's reflector. being extremely careful with the LCD screen, only gently wiping the glass and the FPC cable. Using a dry brush to flick away any remaining debris on the edge of the screen cable connector. Polishing the mechanical vibration motor, and clean every single thread of the microscopic screws. All the dirt and dust has been thoroughly cleaned off, preparing for the high-intensity heat drying process, using a heat gun to drive the last bit of moisture out of the bottom plastic frame. Continue using the heat gun on the motherboard and electronic components to prevent short circuits. All components have been revived, neat and clean, as if they just left the factory. Starting the reassembly process, carefully place the charging port and copper contacts into the bottom locating groove. Place the EMI shield and the antenna module compartment magnetically into the precise slots of the casing. Assemble the camera protective lens onto the back cover. Carefully bend the plastic retaining clips. Adjust the position carefully to press the plastic latches tightly together for a perfect fit. Attach the metal plate, covering the camera dust shield, pressing firmly with a finger so the adhesive sticks securely. Snap the camera module 1 megapixel into the socket on the motherboard. The pressing force creates a slight click. Carefully snap back the ME shields over the processor and ICUS. RF signal. Low. Place the metal heatsink frame of the front onto the motherboard. Attach the pad containing the keyboard vibration membrane. Press the locating pins so the rubber membrane and copper keys make contact perfectly with the printed circuit board. Pick up the magnetic vibration motor and the clips accurately into the groove on the chassis. To assemble the motherboard into the frame, place the LCD panel into the metal bezel tray. Secure firmly the screen assembly with a specialized set of screws to prevent shaking. Place the earpiece speaker into the upper locating slot. Switch to a high-speed electric screwdriver. Tighten the 6 torque screws surrounding the motherboard, pressing the component layers into a solid block. Place the rubber membrane keypad first. Unbox a brand new physical keyboard. Onto the new casing. Extremely rare original cream yellow case. Install the front protective glass. Gently squeeze along the edge so the retaining clips bite tightly into the chassis, creating an absolute seal. Slide the standard mini SIM card into the tray. Snap the latch to hold the copper contacts. Install the standard battery and close the vibrant yellow back cover. Use a microfiber cloth to polish the surface of the display glass. Press the power button. The screen lights up with the legendary Nokia startup logo. Feels absolutely amazing. Set the time. Make a test call to the 900 switchboard. Full signal, loud and clear earpiece. Launch the camera app. The viewfinder works perfectly. The camera module captures sharp images. Access the settings menu. Test the legendary polyphonic ringtones of Nokia, crisp and resonant sound. Connect the pin charger. Charging icon. Battery indicates the charging circuit works completely stably. Check the software. An excellent restoration achievement when placed next to the ruined mud-caked old casing.